Okay, so I was thinking about going over the tests, but um, since I extended the deadline technically till the end of today, I think we'll do that next week. Um, and and so if anybody has some additional questions, we can probably go over that. Yeah, go ahead. I'm sorry?
Dr. Raver, when did you say you extended the deadline to?
Till the end of today. Yesterday, it was till the end of yesterday, but I extended it till the end of today.
Okay. It sounded like you said next week, so it caused a little bit of confusion
Oh,
down there.
okay. Sorry, I didn't mean to cause the confusion.
It's all right.
All right, so on class. Oh yeah, that's not the right class anyway. I mean, that's not what I wanted to do anyway. All right, so we are, and I did actually just make some changes to this recently. So make sure that got in there. Yeah. Yes. So we are on this week 8. Okay. And today, what we're going to talk about actually is we're going to take another step. So we talked about just the basics of Python. We talked about a bunch of different data types, that sort of thing. Then we transitioned to learning about ArcPy and basically running ArcGIS commands using Python. That's what we did for 3 or 4 weeks, probably about 3 weeks, 4 weeks. I'll look back on the schedule, but for a little while. And then now what we're going to do is we're going to spend 2 weeks on discussing tinkering with GIS data at the individual data value level. And first we're going to do vector. That's what we're going to do for the next 2 weeks. We're going to talk about GIS vector data. So basically we're going to talk about going row by row in a vector data set and changing some of the data. I mean, there's all sorts of reasons why we'd want to do this. And it's similar to what happens when you, let's say, calculate a new field. You could definitely do that in what we're going to talk about today. But if you wanted to build some more complex logic into calculating a new field, then you could put into the field calculator. That's one reason that you'd want to do this. Also, we have the ability to tinker with the individual geometries row by row. And so there's all sorts of reasons that you'd want to do that. You might want to actually build. So next week we'll talk about building geometries. You have, some complex description of or maybe not complex, but you have some description of a geometry and you want to actually plot it on the map. You don't actually have a shapefile yet or a feature class. Then you could use what we're going to talk about over the next few weeks to do that. So that's what we're doing. We're talking about that, and then we'll do it with raster data. Raster data for a couple weeks, and then we'll round out the course after that. So we're going to reflect a little bit on what is GIS data. This link actually doesn't have anything to do with this question. This link should have been on the next row, but it didn't look as good on the next row. Okay? So, because there's already a link there. So, what is GIS data? Particularly, what we're concerned about today is what's vector data. But in general, just that statement, what is GIS data? And in general, one answer that you could say is that it's information about our world that contains both spatial information and attribute information. In other words, It contains information about our world, and it's tied to a spatial coordinate or set of spatial coordinates. And that's the general definition of what GIS data is. Information about the world. Vector data, when we say that data is information about the world that's tied to a coordinate, when it's vector data, that coordinate is either a point or a line or a polygon. What's a point? We all know, we should all know what a point is, right? Yeah, X and a Y, sometimes there's a Z, but it doesn't have to be in GIS. Okay. Lines, what fundamentally is a line? I'm not talking about a mathematical line. The line is mathematical line is defined by just 2 points, right? But when we say a line in GIS, sometimes we actually use the term polyline. What is that? Multiple points, right? And a polyline, the reason that we use the term polyline is that a polyline can actually be, a single entity can actually be composed of multiple lines. So what we're saying there is that, let's say we wanted to model a road, but we wanted to model the edges of the road. And so in our database, we might have a line that represented a road, maybe just the center line. And that's a series of points along the center line. However, we may also have, in another database, the edges of the road edges. And those road edges could be thought of as the same feature. They could represent the same road. They could be one row in our attribute table, Main Street. But the line or lines that actually represented that road could be 2 lines. And they would still be the same row on the table. And when we do that, we need to think those are 2 lines. They could be multiple lines. Maybe an easier way to think about this is when we go into polygons. All right. Is it possible to draw a single connected polygon to represent Michigan, the state of Michigan? Right, but it's not a single connected line, right? It's actually 2 rings that represent, and that's actually the terminology SRI uses. What's that?
Gotcha.
Michigan, yeah. Or even Mississippi, technically, at some level of detail, has some islands off of our coast, right? And so if we wanted to represent Mississippi in a great level of detail, we'd have a polygon with multiple rings. So that's a geometry. All right, and now,
What are you, rings again?
rings are the components of a polygon.
Okay.
So that's just what ESRI calls them. So let's look at this, this the second link here. Okay, the second link here, this is a description of how ESRI builds its geometry class. So class, remember from Python back a little while ago, a class is a description of the type of an object. So once we actually deal with these things, these rows in the attribute table, have you ever opened up in ArcGIS, you've opened up an attribute table? One of the columns actually says shape, right? And then in there, it just says a word. It'll say polygon or point or multi-point or polyline or something, right? It always says the same word all the way down. Well, there's actually something stored in that field, and it's one of these. It's a geometry object that's created from this this entity, okay, a geometry. So a geometry always has a type. It could be a point, a polygon, a polyline, or a multi-point. Those are the different types of geometries. A point is actually meaning just a single point. You can have an x, a y, and a z, and sometimes an m. A multi-point is a geometry that contains multiple points. Anybody think of a reason that might do that? They might represent all the locations that you've been to. It's all about representation. Do I want to represent on one line multiple locations, or do I want to represent them on multiple rows in my database? Okay, so that's point and multi-point. Polygon and polyline are always multiple points. Multiple entity things. Even if there's really only one entity. So I don't think there's any islands or any other pieces of Wyoming, right? What does Wyoming look like? Yeah, it's a rectangle of some sort, right? And there's no like little piece of Wyoming that exists somewhere off that the people can escape from living in Wyoming, some other location. So it's still one actual entity, but in the geometry object, it's still stored as a collection of these ring entities, but it's just one of them. So so this is a description, and these are some of the properties that a geometry object has. You can get the length, you can get the centroid, you can ask it if it's multi-part, you can ask it to give you a different type of representation. This is a JSON representation, a WKB, a well-known binary representation. A WKT is a well-known text representation. These are all different ways for it to describe itself. But it's going to boil down to being a bunch of points. A bunch of points, a bunch of points. And those groups of points are the parts. So these rings in a polygon, or in a line, they're not rings, they're just lines. The general term for them is parts. You can ask how many parts there are. In a polygon, there's always going to be at least one part. So you can get the part count. If you want to find all the parts, you can get there. Then you can find out how many points are in each part, and so on. All right. So we're going to experiment a little bit with, today, we're going to experiment with breaking up and looking at the geometry that's inside of a feature class. It's one of the things that we're going to do. Another thing that we're going to do, but we might do it more next week, because there's a little bit of material today. But one thing that you can do is, remember with classes which become objects, you can actually, sometimes they have methods or functions attached to them. So you can ask, for example, you can ask a geometry to give you its boundary. So if it's a polygon, it could give you its boundary. If it's a series of lines, it can give you its boundary as points. So basically, it collapses the geometry that you currently have into one less dimension geometry. So if it was a two-dimensional geometry, it gives you one-dimensional geometry, lines. It gives you, if you have one-dimensional geometry, it gives you the zero-dimension points associated with it. Of course, if you ask points for its boundary, it'll give you an empty set. All right, you can do other things with the geometry. You can ask any geometry to buffer itself. So If it was a line, when you buffer it, it becomes bigger. So you might be saying, well, there's a buffer tool in ArcGIS, right? How is this different? Well, this allows you can go row by row and look at the geometry in that row, buffer that geometry in that row, and do whatever you want with it at that point. You could combine it with another geometry. You could have a very complex rule set for how big the buffer got. So let's say you wanted the buffer to be related to some function, some trigonometry or logarithmic function, to create a different size buffer for every single row in the table. You could do that. That's buffer. You can clip geometries. We're going to actually do some of these. We're going to practice more next week. You can ask for the convex hull of a geometry. That's basically the minimal bounding polygon, such that all angles are convex. There's all sorts of tests and operations that you can do on a row by row basis, rather than saying, I want to do this for this whole data set compared to this whole data set. So these are the building blocks for designing your own spatial spatial tests and spatial operations that might be different than the standard out of the box ones. Okay, so that's so I guess I closed this guy up. 8. All right. So I'm gonna bring up Python, and we're gonna kind of get a little bit more into these questions. So, but before we do, I'm gonna point out that raster data is pretty different. We're gonna talk about raster data in a couple weeks. So right now we're gonna focus on this vector data and how that works. We might actually put this off till that time too, okay? Till next week. But this part right here is how I'm going to get into ArcGIS, and how we're going to. This gets to how we're going to actually look at these data row by row. And so, in order to access vector GIS data on a row-by-row basis, we have to use a different module. It's really a sub-module. So we've got ArcPy, and then part of ArcPy is this DA module. It stands for the Data Access Module. And the Data Access Module allows us to go into the data and tinker with it. Whether it's the where data or the attribute data. Okay, we can get both of them through the use of this module. And this module is set up to utilize something that's referred to as a cursor. Okay, and a cursor is a more general computer science term. It just means that we're going to go row by row through a data set. So all vector data sets are set up as tables. Cursors allow us to loop through. In fact, it's very similar to the way that we loop through files. Remember when we looped through a file and read the file? So a data access module is allowing us to use cursors to go row by row through data. And these terms, search, insert, and update, are roughly analogous to opening a file for reading, for writing, or for read-write, like read it and update it as we're reading it. So if you open up a data set using a search cursor, you can't modify it. So it's always safer, if you don't want to modify it, to open up a data set as a search cursor. If you want to create a new data set, you open it up as an insert cursor because it will always append new rows onto that data set. And then update will allow you to do the same thing as a search, but it will allow you to overwrite that data. The other thing that we need to think about when we use cursors is that no matter which one we use, we will be locking up the data once we use it. So if your script crashes, or sometimes you have to close it in order to get it to work again, because it will be trying to access data that is not available. Not available to be accessed. All right. So I'm going to click on this button right here. Okay. So here's the data access classes. That's what we're going to be concerned about today. That's what we're going to learn about. We're mostly going to learn about the search cursor, the insert cursor, and the update cursor. Okay, these are what's going to allow us to access the data. Okay. All right. So I'm going to open up Python. I'm also going to get some data. I already think I made a mistake on the data. I think I threw all the data into the archive. Exercise 9. Yes, I did. Okay, I'll take this back out of the archive. But if you go into the archive, and you can download this city-i10.zip. That contains the data that we're going to use today. And I'm going to put that in, it's just a shapefile. I'll just put it in CTemp, SPA lab, new, call this week 8. Put that in there. And then another thing that I'm going to do is get a little bit simpler data set that we're going to use for our lab next week. So that's in, oh wait, this is week 8. I was in week 8. It's in both, I guess. M7 data. What's that?
Should we use the My Cities one we created at 4 or 5?
The My Cities one?
Yeah.
You mean from like
lab 2 or 3?
Yeah, no. Don't use that one. Use the one. Okay. So in week 9 and in week 8, there's the same data set. So I put them in both, and that's okay because you're going to use them in both. The example data, I accidentally put it in week 9. So some of the example data, which we're not going to use in the lab today, you could also download if you want. Because I'm going to use both of those in the examples today. So this M7 data, I'll put it back over in week 8 too. But right now it's only in week 9. You actually are going to use it in week 9's data. All right. So CTemp, SPA lab, week 8. All right. So I put all this data in this folder. So it's got cities 10, got the GPS points, got these parks. We're not going to use Actually, we're not going to use the parks or the tracks till next week. But we are going to use the GPS points in these cities. So now I got that set up. All right, the first thing that we're going to do is we're going to use the search cursor to open up a data set and read through the data. And we're going to start off by just doing a simple operation where that's all we really do. So it's going to involve a for loop. Search cursors can be iterated using a for loop. Just like, well, kind of like a file. I'm going to go through the file. For each line in a file, we're just going to go through for each for loop. Now here it says that when we create a search cursor, it's going to return an iterator of tuples. Okay? Basically, it's going to return a bunch of tuples that we can iterate through in a for loop. What's a tuple? What's that? Yeah, it's an immutable sequence. So it's basically like a list, but it's immutable, and that's the only real difference. So it's returning a list of kind of like a list of lists. We could treat it just like a list of lists. So we can say for each item in this search cursor, once it's done, give us the values. Okay? So that's the way we're gonna use it. Okay. So here is there's a little note. So there was an older way to do this called the arcpi.search cursor. Okay. And 4 years ago, ESRI switched over and started using the DA.search cursor. But they kept it in for backwards compatibility. But it's a little bit different in the way it operates. You can't get the geometry as easy, and so that's why they switched over and put it in a new module. All right. So these are this is the way you create a new search cursor. You give it the name of a table. You give it the field names as a list or tuple. Okay. What do you think that means? The field names. Doesn't a table already have field names? Yeah, the top columns. But one of the nice things is that you can tell it, I don't want to see every single column in here. I'm only concerned with maybe 2 or 3 columns. And so that's helpful. You can put an asterisk in there, which will give you all of the fields. It'll give you a list of all the fields. So, I just think it's really convenient to not have to deal with having 100 fields, just dealing with 2 or 3. So, if you give a list of field names, it'll only give you those field names with which you're concerned with. Okay. Optionally, so remember the little squiggly brackets? That means optionally. Optionally, you can give it a where clause. What would a where clause do? What are other situations where we use it? Like we've actually used one in the search tool, or the select tool that we ran the last time we met. What if I did this? What if this table represented cities, and I said where population was greater than 10,000 here? Yeah. So in your search cursor, you're only going to get those that meet that criteria. You're not going to get every single value. So that might be helpful. You can optionally, if you want, you can give it a spatial reference, and it'll transform the geometry data from that spatial reference that it's in to the spatial reference that you're asked for. You can also ask it to take all of your complex geometries, your polygons or lines, and explode them out to just points. If you don't really care about the fact that there are multiple rings and multiple parts, you just want all the points, then you can do that. And then you can also see that a SQL clause, such as order by, that's one of them, or group by, if you want to further group your data out. So let's practice implementing this. Here's an example down here, a code sample of this data. But let's just copy this first example here and use it on our data instead of their data. Because we can't even see the output, so this isn't that interesting. So we copy all of this, and I've got my Python window open. I make a new file, paste it in there, and then I got to get my path here. So there's the path to my data. I just copied and pasted it from where I unzipped my data. So we gate there. I'm going to open up Arc.
How far, Dr. Raver, on the path, so you need to open up the file the data's in, and then copy the path from there, or just the file that the data folders are in?
You just need the full path to the data. So I think it's easiest to go to the folder that the data is in and copy the full path. Is to actually do it through our catalog. I've opened up our catalog. So if you open up our catalog, you could, if you open up our catalog, you could navigate to it. I put it in C, temp. I put it in CTemp, SPA lab, week 8, and then I could actually select the data set I want, which I'm going to start with GPS points, and hit preview. Now, there's my preview. Now this path that's up here in this corner that's hard to see because ArcGIS doesn't look really good when it's on the projector. But that path right there, if you copy that path, you'll get the entire path that you want down to the individual data set itself.
Can you show us where that path is located again?
It's up here in the upper left-hand corner once you navigate all the way to wherever you've saved it. Just a second. What's that? So setting workspace makes it easier, like if you're accessing multiple files or in the same file, in the same location. Setting the workspace is... So the question was, what's the difference between doing this and accessing a workspace? So if I had gone arcpy.env.workspace equals this part right here, then I could just write this right here, and that would work. So this means that forever after, I don't have to type the whole path. But if the data isn't in that location, then I need to type the whole path. Like if I'm always accessing data in that same folder, in that same workspace, then I'm good. Like if I want to now access something else in that same directory, like this data set, then I could just say next data set.
If you have a script and you save it in a certain place, does that establish the relative path?
So in a script, just in a raw script.
You save that script to that path with the workspace path.
Yeah. The path is hard coded into the system. Now remember when we talked about executing a Python script from a particular path, that sys.argv 0 is the path to the executing script. And so if you got fancy, you could always check that path and use that path as your workspace, and then your script would always work, assuming you executed from command line. The other way around this is if you turn it into which we're not going to do this week, we're not going to talk about toolboxes, but if you turn it into a toolbox, the toolbox itself knows where it's executing from, and you can say set relative paths, and as long as you move the toolbox around, it'll use that as a relative path. But if you hard code it into your script like this, you're forcing that path, and if you move it around, it doesn't update that. All right. Cool. Any other questions? I know at the time we were getting 2 questions from the code. Stand up here. Are there another question from the code? Code? Oh. Can you all hear me on the code?
You can't. I can hear you.
Okay. Y'all are good?
We're good.
Okay.
Yes, sir. Thank you.
Oh yeah. Okay, so we got to. So this would work, or we could put this path down here. We'll just leave it for now. Okay. The next thing is that we could optionally just put a star, but we're going to try to get the fields off of this data set. Now, if you look at this data set, I'm going to go back to GPS points and go to table. There are basically 3 fields. There's really 4. The FID field, the shape field, the time field, and the animal field. So these are GPS points that represent the movements of an animal. And so these are different animals. 1, 3, 2, those are just coded. All right, the time of day, and then the shape. Okay. So what we want to do is practice getting these values row by row into our Python script. So what we can do there is we can change our fields names here to the field names we want. So let's change this to time. Is it all caps? Nope. Time, animal, and the shape is kind of unique, because this is how we get what we want to get here. Let's go back and look at the help to help me explain this. Okay. If you go back up to here to field names, we can get a lot of different types of information about the shape. If we just want the entire shape object that was created from that geometry class, that's just shape at. That'll give us the geometry object. And we might want that sometimes, because that will allow us to do all sorts of things. Like we could calculate the centroid, we could buffer it, we could do whatever we want with it. That's just saying the shape at. But let's say that we don't really care about that. We just want to get the area of the shape, or the length of the shape. Or we just want to get the centroid. So first, let's just get the centroid. A tuple of the feature centroid. We're going to do that first. So that's what's already there. I'm sorry. It seems like I switched back too quickly. So I'll leave it up here for a second. So we've got time, animal, and shape at XY. What this is telling us is that we're going to get the shape XY values, a tuple of the XY values. All right, I'm going to delete this comment since it doesn't really have anything to do with what our data is going to do. All right, I don't know if we've used this syntax before, this with archi.va. I'm going to leave this here, but then I'm going to show you the equivalent statement that would work just fine. and it's closer to what we've done before. All right, so I'm going to run this. I'm going to save this as example 1 in actually, before I do that, I just got to sync and make sure that online is the same version. Oops. There we go. I'm gonna sync it so that it's because I changed it from my office, not this computer. Okay. So now I can save it. File, save as C temp SPA. Sorry, I keep getting 8 and 9 confused. All right, there we go. So I'm going to call this 2018 example 1.py. The space shouldn't be a space there. Okay. All right, I'm going to run this. Sorry, what? The same name as what? That's an exception. Yeah. So this just needs to be the same as the values in here. See how we did this first one, shape at x, y. The feature central. Right. Yeah, if we wanted to get the actual value in the shape field, it's not much different. It just looks like this. So this would be the actual value in the shape field. Shape at x, y means that we're getting the centroid. And the centroid of a point, these are points. You see this? I showed you the points. The shape, the center of a point is that point. So this is just a quick and dirty way to get the actual point. As you'll see in a second, that if we got the geometry, in order to get the point, we'd have to ask for the first part, and then ask for the first point in the first part, and then get the geometry, which we'll do in a second. All right, so this was the code that ran, and this was the result. You see how these are just the values? These two are just the values in the table, and this is a function on the geometry that returned the centroid, the x and the y. So these are the x and the y coordinates of each row, of each, the x and y coordinates of the centroid of each point in the row by row. These are the rows, and then these are the values. So we're getting the centroid out of there. Okay? Now, I did tell you that I'm just going to call this example 2, because just to show you that the ArcGIS help wasn't totally weird, we could change this and say, and those two, well, sorry, and then unindent this. Dedent region. So those are equivalent statements. They'll work the same. Both of those two that we did. It just said, it just used that with something as cursor. But this will work just fine. It'll produce the same result. I'll go ahead and run it. And Did it already run? It might have already ran. Oh, there it goes. So it ran.
Why are you 6 XYs for one point? Each point has 6 different XYs.
No, each row here is 1 point. So this is the value of the time field. This is the value of the animal field. Here, I'll do it on here. This is the value of the time field. This is the value of the animal field. This is the value of the x and the y. So there's just one x and y. I mean, it's good. It's good to try to understand. So help me if you're still confused.
I think I'm tracking. I was just looking at the attribute table and program.
Oh, okay. Over here.
Yes, sir. I see where each animal has 6 different. I'm tracking.
Okay. Yeah. So good. So like, yeah.
So the best practice should be the way you just did it, or example 1?
They're equivalent statements. I don't think that there's one or the other. The argument, I know why they're doing it. The argument for doing it this way is that it groups the cursor into a separate indentation block, so that the cursor is actually created as part of an indentation block, and once you exit this indentation block, the cursor object ceases to exist, which could be beneficial if you wanted to recreate another cursor object later in your code. So that would be the argument for it, is organization.
Okay.
But as in terms of efficiency, it doesn't make any difference. Sure. The next thing I'm going to do is show, I'll call this example 3, and I'm going to get the whole shape geometry rather than just the XY. Just the centroid is a better way to say that. So if I run this again, I'll just put this down here so that now when I run this, it's actually going to say geometry object, because that's the way it represents it. See how it says geoprocessing describe geometry object at blah blah blah. So it's an object, and if we want to interact with it, we have to use those. We have to use these methods because it is a geometry object right here. So if we want to get the centroid, for example, we can. There is a tool to get the centroid. But what does it return? It returns a point object. So even doing something like this, where we say row2.centroid, now it's going to say something slightly different. It's going to just say that that's a point object. Oh, I'm getting that message now. I fixed it on so many computers this week. Okay. What's that? Nan. So this is a point object, and point objects do convert to text, so I was wrong. But this is an X and a Y, a Z, and an N. So points in ArcGIS by default have X, Y, Z, and N. And I don't know why they have N's, but it's just a way to attach another attribute to the point field. All right. So now we're just going through row by row and getting the data out of it. So now let's look at a little bit more complex data set. Here's all the cities in Mississippi. Well, not all the, maybe it is all the cities, I don't know. It's all the cities at least of a certain size. So, here's our area of the world if our area is Hattiesburg and south, okay? So this is Hattiesburg right here. You all know that Hattiesburg has this like weird little tail that comes out of the bottom. What city is this? So this is Purvis. So this is Lumberton. Yep. What would be the next one south? Poplarville, that's right. And then finally we've got Picayune. Right, so this is like the old 11 corridor. I mean the 11 US 11 corridor. Most of these cities don't actually exist on 59. They're just off to 59, right? 59 bypassed them all. Okay. So I don't think there are any cities in Mississippi that have like a piece that goes on another side, but there is a city right here. What city is this? Gaucher. I wonder why Gaucher has a piece. Did you see this piece I'm talking about? Like, these people must have really not wanted to live in Gaucher. Same up here. They got two of them. Okay? So this is a ring, and this line that goes around the outside is also a ring. Whereas, most of the cities, I can't see any other cities that are as complicated. Although Purvis is fairly weird shaped, it's not. It's still just one polygon. Okay. Whoops! I didn't mean to start ArcGIS. So what I want to do is write a little script that'll help me to see which cities in Mississippi have more than one part, or more than one ring associated with them, or more complicated features. So what I'm going to do is just go through row by row, and all I really care about is outputting the city name and outputting the number of parts that are associated with that city. I didn't even mean to start ArcGIS, so I'm going to close it right back down. Okay. So let's look at the attribute table to determine what attribute table I'll need. Attributes. So there's a field called name 10. I'll need that one. And I'll need to get the entire polygon shape and then ask it for its part count. So I'm going to do that real quick. So let's modify this script. Did I open it twice? Oh. Okay. So we'll modify this script so that it uses that other, and since it's in the same place, we could call this example 4. We could just change this part to city with an I at the end, 10.shape. City I10 shape. And then we just want the name 10 and the shape. That's all we want. So now this won't work here because we didn't actually discuss going all the way down to this point. But this print, what is this? What is this doing? We did show this once a long time ago. It's going row by row, and it's printing out. First of all, cursor returns a list of what did it say? Or an enumeration of tuples, right? So what does that make row? If cursor is an enumeration of tuples, what does that make row? It makes it a tuple. Because cursor is a bunch of tuples, so each row is a tuple. So when we say format 0, 1, 2, we're saying throw in the first item in tuple, the second item in tuple, and the third item in tuple, in that tuple. Now how many items are going to be in tuple if I only ask for 2 fields? But there's only going to be 2. So if I do this, it's going to give me that error. You guys remember, you guys ever get the error, index not in range of variable or something like that? That means that you asked for a number that was too high. There's not 2. Only 1. So we'll just get rid of this other one. And by the way, how do we know which one's which? It actually, so 0 and 1, it doesn't really matter what order they are in the attribute table. So in the attribute table, shape is before name, right? But in the cursor, we ask for name first, so that's 0. That's the name. And then that's the shape. So you can ask for them in different orders and they're in the field. And they'll show up in the tuple in different orders if you do that. So now if I run this guy, all I'm going to get now is a column that has the name of the town, comma, and then, I'm going to have to do this every single time now. Name of the town and the whole geometry object. Like the whole thing. So it's just going to say geometry object. This might take a little bit while longer to run because it's huge. But, what's that? You got an error? Okay.
Yeah, you left the curly brace Q in the last line.
Thank you. What did yours say? Like this? Yeah. That's expected. That's what it should be doing. Is this what yours looks like? Yeah, okay. So yeah, that's what I'm saying. So Faulkner and its geometry object, but it doesn't have a way to actually type it out. It's a big thing. It has all those properties and methods that we talked about. So it just prints this, and it tells you where its address is in memory, like you even care. And then Walnut, same thing. Ripley, Dumas, Blue Mountain, Pass. We all know where these places are, Biloxi, Long Beach. Okay? So this is that big object, and we need to extract some useful information on it. For example, we may want to know how many parts it has associated with it. In order to do this, let's this one, the code.
Yes, sir.
So let's go back to here. Gotta go around again. There we go. Let's go back to here and look at the polygon, because these are polygons. We know they're polygons. And so with the polygon, we can get the part count. That's what we want to get. We could also get the point count. Let's see, we're just interested in seeing how complex. We wanted to measure the complexity of this polygon by finding out how many points it has. Okay? Associated with it. And that was one measure of complexity. Okay, so let's change this to row dot part count. Like that. I'll save this as a different example so we have incremental examples. So now we're going to get the the name of the town, comma, the number of parts in that town. So for most of them, we should get one. But we noticed a town like, was it Gaucher, that we saw had a few different parts to it. And it's not ordered. Laurel has 4 parts to it. Laurel's close by. Let's see why Laurel has 4 parts. But anybody see Gaucher? There's Ethel, wherever Ethel is. Monticello. I canoed from Monticello to Columbia before. It was fun. All right. Let me see. Well, let's just look at Laurel, and then I'll try to find Gaucher in the table. Oh, it is. Probably. All right, so this is Ellisville, and that's Laurel. These must be considered different parts. They touch by a single point. I don't know why they would be showing as individual, but they do have some. So another thing that we could do is you could change this back to 2 and then get the row 1 dot point count. So now we're going to get the number of parts and we're going to get the number of points. The total number of points are used to create that big polygon. So the number should be quite high, unless you had like a Wyoming style city that had 4 points. But it's kind of interesting. There's a pretty small one. Tishomingo only has 90 points in it. Ooh, Gatman only has 36 points. But he got less. But that's getting there. Okay. Yeah.
How will we look at 2 when we don't have name, 10, and shape at?
Right, because this actually corresponds with the number of values I'm giving it in this format function. So here, I'll show it on here. So this isn't corresponding with this. This is corresponding with this. So for each value in the format function, there needs to be one squiggly number on that side to coincide with it.
Okay, I did that, but I don't, my result doesn't. I get the city getting comma 1, all the way.
Does yours say part count and then point count, or does it say part count and then part count?
Oh, you're right, I did do part count, so that, I just missed that subtlety. Point count instead of.
Point count, part count, point count. What's that?
I have part count and point count. I looked at the results
Are you using the city data set, or are you still using the
no, so I'm on the city set.
okay. Are these 0, 1, and 2, and these say 0, 1, 1?
I didn't have my 2 code right back.
Okay, thank you, that fixes it for me. Okay, so the curly spaces 0, 1, and 2, you said those correspond to that row. So we're referencing the row, the component of the row that we selected in C line 1. Is that right?
Yeah. So Maggie's right that the square brackets represent the values inside of the field. So the square bracket 1 represents this value. The square bracket 0 represents this value for each row.
Oh, okay, that's where I'm thinking.
The 0, 1, and 2, the squirrely brackets here, squirrely. The squiggly brackets, curly brackets, they represent whatever's in the format thing. So you could have totally different, I mean, I could put a 5 right here instead of this, and it would work. And it would just put 5 over there. Well, A would have to have a value. If A wasn't declared, it would die. Unless I put it in quotes, then it would be a string. It'd be all good. All right.
Okay, thanks.
Absolutely.
Get different results than what you have. I have numbers with parentheses around them
Under here, does it say shape at anything? Does it look like mine?
now. Now you found it. I had some parentheses that girl back.
Okay. Ashley.
So, in the format part, those are indexes for this field, right? Like the square bracket, the row 0, row 1, that's just representing your index. And then the squiggly brackets are just telling you how to format.
Mm-hmm. Yeah. Yeah. Yep. I mean, yeah, so I'm going to comment this line out for a second. So maybe we shouldn't have used the fancy SRI example, but this this right here should be basically the same, except for it's not actually converting. It's converting it to string on the fly as it's actually printing it out, but it's going to give us the same data, and it'll make it maybe slightly less confusing. So that's an equivalent statement right there for what we're doing. Now, if we wanted to write something like town name, colon, and then parts, colon, and then point count, then this would be a better way to do it. Because if we did it this way, we'd have to like write, you know, we'd have to put a bunch of plus quotes and stuff like that. So like this would be town name. Right? So now if I rerun that, you see the utility of using the format, because to reproduce that would be kind of messy. I mean, it'd be easy, but see now I have it like kind of, I have labels associated with it. If I want to reproduce that here, I'd have to go like this. Town name plus str. See how it wouldn't be very pretty, because you have to convert everything as a string. So anyway, those are equivalent statements. I'll just save it like that. Okay. So far, you know, kind of, I guess, kind of mundane. But what we're going to do now is one more thing before we get to maybe an example that would be a little bit more concrete. What I want to do here is to practice going through the parts inside of a part count. So it's going to be a loop within a loop. All right? And to do that, let's just get, let's change this. Let's go to Laurel. So, actually, here. I'm going to save this as something else. File, save as. and we're going to save it as 6. And then I'm going to put an if statement in here. If row 1 like that, if the part count is greater than 1, then do this. Okay. What's this going to do? I'm going to comment this out for now. Right. It's only going to print those cities that have more than one part associated with them. So when I run this, I'm not going to get all of the cities in Mississippi anymore. I'm just going to get those that that are greater than 2 or greater than 1. Okay, so that's the code. All right. And then what I'm going to do now is I'm going to practice iterating through each of those parts. Okay. So if I'm going to go show back here. No. I'll go like this. For P in row 1 I could just call this part. Maybe that'll be better. So now it's going to iterate through and print each of the parts inside of the overall. I'll go back to there. Make this smaller. There we go. All right. Now you can see down here it said that there were 2 parts, and it gave me 2 of these objects that are called an array object. You can see here 4 parts, four things that were these array objects, and so on. Okay. Objects, and arrays. An array object is a group of points. Let's look back in the help here. I'm on Polygon, and I can go to Properties. Returns an array. So an array of point objects for a particular part of a geometry, an array containing a number of arrays, 1 for each part. Here. So now I could say for point in part, print point. So now I'm saying, okay, I'm going to go through each city. For each city, if there's more than one part, I want you to give me each part and print it. And then I want you to go through each of those parts and give me each of the individual points in each part. So it's going to be a lot of, I'm just going to go back like that. It's going to be a lot of individual points. See how it's just going zzz, all the way through that. But in some cases, there's 2,000 points in a part. I'm a little bit puzzled as to why Gaussier is not multiple parts.
Those big old decimal numbers are locations in our
No, these numbers right here that are flying through, those numbers are actual coordinates. Yeah.
Before, in the prior part, before they had the ABCD part of it, you had to stand way far up.
Yeah, here, I'll just,
Reminded me that, counting a binary number.
yes. Let's see if this does it. Yeah, so when I run this one, this is what you're talking about. This one is gonna say, so these are actual coordinates. This number is an x coordinate, that's a y coordinate. When this other one runs, this number right here, that's just a location in the computer's memory. Yep. Yeah. All right, so I'm gonna close this guy. All right, so we're going through, and we're diving way into the points. Okay, this we'll provide a good example of why we might do that for sure next week. Okay, so let's do one more practice. arcpy.da.search cursor. Well, let's go back to example 5. I'm going to close 6. So 5. Let's use the where clause argument under the search cursor and see how it says right here, where clause, right? Let's just show an example of that. So we could do something like name 10 equals, actually here, how does that work? You guys remember how that works? SQL like, the like operator? Yeah, okay. Okay, let's see if this works. I'm using the like operator. The like operator is not used as much as the equal operator. Okay, so what this is saying is it's going to look and see if name 10 is like this string, and this is a wildcard, this little percent sign. So what that's saying is if it starts with a G, then include it in the search cursor. If not, don't include it. So it's going to include at least Gulfport and Goshen, Glendora. Find out if there are any more G named cities. So these are all the G named cities there. Greenville, Gunnison, Grenada, Georgetown. I like that place. I don't even know where it is. It's my first name. Okay. All right, so that's an example of using the where clause and why you might use it. Okay. So the search cursor basically just lets us search for data. So you might use this for creating reports or searching for a particular field that pops up in your data set and manipulating and being able to report a manipulated value to out into a report. This could be a report right here. All right.
use this to search for an empty field and then replace it with null?
Well, we're going to talk about updating here in a second, but yeah,
Okay.
you could, exactly, yeah. go ahead.
Mine just keeps referring to this.
Yeah, my guess is. Well, what's happening is it's getting into this if statement and nothing is there. So there's no rows in your cursor, I don't think.
So you're really
Well, it might work. Maybe last name can probably have to.
I don't think you know.
What's that?
So we went back to example 5.
Oh, yeah, I went back to example 5. Okay, all right, so that's, what's that? Okay, one more thing that I wanted to, oh, yeah. So let's do an example of, we've got a search cursor. Let's do a update cursor. So we're going to do a search cursor, an update cursor, and we'll save a insert cursor till next week. We'll talk about insert cursors next week. So an update cursor is going to allow us to change the value. Like the question from the coach just came up. What if I wanted to search it and change those values? In order to do this, I think what I'm going to do is make a copy of this data. It doesn't really matter because I downloaded it, right? But this way I'll have it. So I made another copy of that data set. I'm going to change this data. So I'm going to make a copy of it just in case. But that's what you're doing. When you do an update cursor, you're changing the values in that data. Okay? So if I go here and update this using an update cursor, I'm going to change the values in the data. Okay, so
Which data set are we working on now?
still the city's 10. I'm just gonna change one of the values. All right. So in order to make this an update cursor, first of all, let's change it again. File, save as. There's none with a missing value. Save this as 7. I'm going to delete this this part right here. Okay, I just deleted that part. And I'm going to change this to an update cursor. Okay. Now, if I run this right now, it's going to give me the same as my old data. It's going to do the exact same thing, in fact. There's no changes that are going to happen. I can use an update cursor as a search cursor. There's no problem doing that. But I also have the additional power to change something along the way. Okay. So see how it didn't really do anything? So let's go to the update cursor. And if we look at the example, you can see here that there's this syntax right here, I'll do it on here, that says cursor.update row, and you give it the same row back. Like, you change the values in the row, and then you give it that row, and it'll save them out into there. So what I could do is, I've only actually gotten 2 values here, right? So I could say row 0 equals row 0 dot, or sorry, plus, I don't know why I would want to do that, but what am I doing here? I'm up.
Town into each field?
Yeah, I'm adding the word town into each field. Okay? I'm just adding that value in there. Now, if I just do this, and I run it, it might show up in here, it probably will actually, because I've modified that row, but see how it put, Ripley Town, Wilmington Town, Faulkner Town? But over here, it won't show up here yet. What's that? Tyler Town. Yeah. So it didn't show up there. The reason that it didn't show up there is that I didn't commit it to disk. That's this line of code here. To commit it to disk, I actually need to add that line. Now, it'll take cursor and update the row with the row values. I could even modify the points. In fact, we'll do that in a second here, but I'm going to run this guy and run it again. And once it gets through, by the way, if you're looking at an R catalog like I'm looking at an R catalog, you may get an error. But that's why I clicked off of it. So now I'm going to click back on it. I look in the table, and now everything is town. Natchez Town, Crosby Town. Sounds like I'm old-timey. Mendenhall Town. All right. It worked. So you could say, oh, I could do the same thing in calculate field, and you could. That's true. All right. It's only in cases where you'd want to do something that's a little more complicated that this has a lot of utility. For example, here is an example here. Let's try to interpret what's going on here. I mean, they have pretty good comments, but so they're going through. Yeah.
Should it say town after you want the city too?
Yeah. No matter what, because our logic just said append town to all of them. Our code just said add town to everything. We just appended town onto there. Okay? We could even, now, if we wanted to return it back to the way we had it, we could comment this line out and say, -4, TOWN, maybe 5. Save as, example 8. So now I reversed what I just did, and now, of course, it looks like it's working. So now I have all those names taken back to their original names, just by using a slice of the original string. Since Space Town is exactly 5 letters, I just said I want to see everything from there. It's like, I also invented a new emoji at the time, doing it. It's like a weird smiley face on the side. I don't know, it might already be an emoji. Okay. So, if I ran this again, it would cut off 5 characters from every single one, which is not what I want. So don't run that again. But if I deleted this and ran this one again, it would add town back on to every single one. So I could write some logic in here. I could say, if this value was a certain size, make this have the word town on the end. If it's larger than that, maybe have the word city on the end, or something like that. Okay? All right, going back to what I was going to say over here, is this logic right here says, it basically creates a bunch of classes. I know that if you've been in Geography 217 with me, there was a time when you had to painfully, maybe not painfully, but you selected a bunch of soil types and you reclassified them, and then you selected a bunch of other soil types and you reclassified them. You selected a bunch of other soil types and reclassified them, right? Well, if you could write a script. That's basically what this is doing. It's saying go through row by row, and just instead of doing this in 5 or 6 steps, we're just going to go row by row and say if it is a certain value, reclassify it as this. If it's a certain value, reclassify it as that, and so on. So you could do the same thing with a script rather than with another way. You could also use it to build, because you can buffer based on a field, so you could use it to build a buffer distance a column. How would you add a new field programmatically? What's the best way to add a new field? It's kind of a trick question. Yeah, you just go back to the old way and add a field that way. So you add a field in ArcPy, and you then, if you wanted to calculate a value into it, you could use the data access to get into it and change it. Okay. All right. Good. So you can delete the current row. You can that'll remove it. So if you delete it, it will disappear from the data set. You could also in either data set, we didn't discuss this, but either type of cursor, you can reset the cursor. You don't want to do that inside of a for loop because it'll be infinite. But if you were doing it inside of a while loop and you had a reason to, you reset it, it would start back at the first row and do it again. Okay. So that's search cursor, update cursor, and we did some geometry stuff. And I think we did all the geometry stuff that we need for this week's lab. And we're going to do some more geometry stuff on next week's lab in week 9. And we'll get a little bit further on that. So here is week 8. And make sure, yeah. So we didn't expressly talk about finding areas and distances, but we will when we actually go to implement the lab here. So for today's lab, what we're going to do is mess around with geometries a little bit more. So we're going to create 3 new fields, and we're going to calculate these landscape metrics into the fields. Okay? So what we're going to do is get some data about the shapes and come up with a few values that tell us how weird that shape is. So we can find out once and for all which city is the weirdest in terms of shape in Mississippi. Just kidding. But that's kind of what we're doing. But, it's really for all sorts of reasons. Some people, well, I talk about it in the lab, but some people study this sort of thing as a if you wanted to just say, well, the cities in this region, they're shaped different. Well, what does different mean? Well, there's different ways to measure the shape of something, and that's what the lab is going to talk about and say, okay, well, the shape index or the perimeter to area ratio in these areas is different than they are in these areas. Alternatively, that's more of a kind of a social construct, a city limit shape is. You could be using it to study like landscape patterns and say, okay, well, if I have a home range for a number of different species, the home range shape of this species is much more compact than the home range shape of this kind of species. But you would need a way, it helps to have a way to describe that with a number rather than just saying what's this big. So anyway, we're gonna practice doing that in the lab. But let's let's take our break now because it's 2:40. That's about what time we usually take our break. and I'll cut the video, and we'll come back and we'll start up the last.